Spring Boot 3.1 introduced support for Docker Compose to make local development easier. Typically, while building our Spring Boot applications, we might talk to SQL databases, NoSQL databases, or message brokers like Kafka, RabbitMQ, etc. So, this Spring Boot's Docker Compose support makes it very easy to automatically run those services in Docker, and your application will be automatically configured to talk to those services. So in this video, we are going to learn how we can leverage this Docker Compose support and build our application and run those services locally. So let's get started. Let's say we are building a simple application which is exposing a REST API, and we are going to use MariaDB for this service. So here I have selected the starter Spring Web. I'm going to use plain JDBC, and I'm going to use Flyway for database migrations, and I'm going to use MariaDB. And we are going to use some validations, bean validations. So now if I want to run this application, I need to either install MariaDB directly on my laptop, or I can run MariaDB in a Docker container. Okay, so earlier I used to create the Docker Compose file, and then I need to configure MariaDB, and I need to provide these properties in my application.properties file. But now with Docker Compose support, I can go ahead and add Docker Compose support here, and if you try to explore what is going to be generated, you can see here in the pom.xml there is a dependency Spring Boot Docker Compose support with optional of true, because we don't need to package this dependency while actually running in the production. This is only for local development. Okay, so now in addition to this, there is a compose.yaml file generated, and depending on what services you have selected, what starters you have selected, it's going to add some of the dependency. Since we have selected MariaDB, it is adding this MariaDB service in that compose.yaml file. Okay, and if you notice these ports here, it is only mentioned what is the container port. It's not mapping it to a fixed port on the host itself. Okay, so let's generate this application and try to run the application and see how it works. I have generated the project and import that into my IntelliJ IDEA. And the first thing I changed is in generated compose.yaml file. If you take a look at this compose.yaml file, image MariaDB latest. So by default, they are going to use the latest tag, but it is highly recommended to use the specific version that you are going to use in your production. So I have changed it to 11.3.2. And if you want to customize these properties like what is the MariaDB database password and all, you can change it. Otherwise, you can still go ahead and use the defaults. And as I already mentioned, it is only mentioning what is the port that is going to run MariaDB inside the container. We are not mapping it to a fixed port on the host. So this is the compose.yaml file configuration changes. And then I have created some basic implementation of our database interaction. So here I have an entity, not a JPA entity. It's a record, a bookmark, and with few properties. And then I have a repository which is using JDBC client. So this is another new addition within the Spring Boot 3, and instead of JDBC template, you can use JDBC client. And we have a few methods implemented: find all to load all the bookmarks, find by ID to load only one ID, one bookmark for the given ID, and to save a bookmark. Using JDBC client, we are implementing these three methods. And then we have a bookmark controller, which is a REST API controller here, and again we are exposing three API endpoints to get all the bookmarks, to get a specific bookmark by ID, and to create a new bookmark. Nothing so complex here. And this is the code we have, and it's a simple create bookmark request which takes only a title and URL, which we are using in create API endpoint. Okay, it's a simple implementation. And if you take a look at our application.properties, here we don't have anything configured, not even data source properties, nothing. Okay, so under DB migration, as I mentioned, we are using Flyway for database migration. So here I have a simple script to create a bookmarks table, and we are inserting some sample data here. Okay, so this is we have, but in order to run our application, Before Spring Boot supports Docker Compose out of the box, even though you have this compose.yaml file, you may have to explicitly run this using Docker Compose up or something like that, and then you need to configure your application data source properties. So usually you configure Spring data source driver class or JDBC URL, username and password. So all those things you usually need to mention that. Okay, with Docker Compose support, you don't even need to configure those properties. And when you run this application, now if I try to run this application, it is going to start all the containers that are defined in this compose.yaml file, and then your application, Spring Boot application, is going to be automatically configured to talk to these services. But how does Spring Boot knows which properties to configure, and how does it know? Like, there is a set of services that are automatically supported by Spring Boot. Not every container, every technology you can simply define it here and then expect your Spring Boot application to automatically figure out how to use that. Spring Boot supports a set of known technologies that are going to automatically support it. So if you go and take a look at your Spring Boot reference documentation, so there is a Docker Compose support section. Here you can see what are all the services that are supported out of the box. So here you can see there is a wide range of SQL databases. You can see here Oracle, MariaDB, MySQL, MS SQL, Postgres. So these are all automatically supported, and also there is MongoDB, Neo4j. So there are RabbitMQ, and if you notice, there is no automatic support for Kafka, but it supports RabbitMQ. So you need to check whether whatever the service that your application is going to use is automatically supported or not. Okay, so now we are using MariaDB, which is automatically supported, and here you can see the application is started successfully and it already applied flyway migrations. And if you take a look at this database URL, here you can see JDBC colon MariaDB, and then this is a local host, and the port is not 3306 but 51864. Why? Because when Spring Boot automatically start up these services, because it is not mapped to a fixed port on the host, it is going to start the database MariaDB on a random available port on the host machine. So I am using this Portainer GUI tool here just to manage the containers. Here you can see this MariaDB container is started, and if you take a look at this published ports, 51864 on the host is mapped into containers 3306. So this is going to be a random port. It is not a fixed port. Okay, so even if you are running multiple Spring Boot applications using say MariaDB, they are going to start on different ports so that there won't be any port conflicts. Okay, so this is how simple it is to use Docker Compose support. You configure one of the supported technology here, and your application is going to figure out how to talk to this service. So it is as simple as that. Now, just to make sure it is working fine, let us see to invoke an API endpoint and it is really working or not. So here I can say API/bookmarks, and I see the response here. And similarly, I can go ahead and create a new bookmark here, 201 created. So this is working fine. But what if I want to use a fixed port instead of a random port? The reason being, maybe I want to connect to this database and then see the data in the database tables, but here every time when we stop and restart, it is going to pick up a new random port, and that would cause a little bit trouble, right? So in that case, you can actually specify the fixed port, and then let us stop this application. And also you need to understand one thing, like the default configuration is in such a way that when you configure your services and then when you start your application, it is going to start the containers. When you stop the application, it is going to stop the container as well. Okay, it is just stop the container. Now if you restart this, okay, let us restart this application and see how it behaves. Now that we have mapped to a fixed port on the host, you can see it is restarted. The same container is going to be restarted. This time it is published on the fixed port 3306 on the host as well, so that you can directly connect to this using any of the client tools. Like here I am going to use database tool provided by IntelliJ IDEA Ultimate Edition, or if you want to use dbeaver or something like that, you can use and then connect to it. So here I would say probably I can use MariaDB with MySQL itself, and let me connect to it. So the user is root. Okay, let me connect with Siva. Password is secret and database is my app. So it is connected. Fine. So here I can see the tables that are created. Okay, I can connect to this like this. So that is one of the reason, if you want to map to a fixed port, you can consistently use the same port for connecting from any database client itself. So as I mentioned, whenever you are starting the application, it is going to start the container. Whenever you stop the application, it is going to stop the container as well. But during the development time, you keep changing the code and then you keep restarting the application. But every time whenever you restart, restarting the containers is going to be a little bit slow down, right? So we can customize that so that it is going to only start once, and then every time you restart, it's going to continue run in the background. Let us say how we can configure like that. So here there is a property called lifecycle management, and there are three options: start only, none, start and stop. The default one is start and stop, but we can change it to start only, so that it is going to start, and then when you stop the application, still the containers are going to continue to run. And then you can keep changing your code, and then you restart application and it is going to continue talking to that container. So now let us go ahead and start this container, start the application, and you can see the container is started. Now I'm going to stop the application, but this time you see this is continue to run in the background. Okay, so this way it can be continue running in the background, and it will be a little bit faster during the development time. You don't need to stop and then restart the container every time you change the code. Okay, this is one improvement. Okay, now we learned how to use the services supported by Spring Boot Docker Compose support out of the box. But what if I want to use some technology that is not supported by Spring Boot Docker Compose support out of the box? For example, here in this list we have seen there is RabbitMQ support, Redis and few others, but there is no out of the box support for Kafka. What if I am working with an application and that is talking to Kafka instance, right? So can I use Docker Compose support with Kafka container? Yes, you can, but there is a little bit more work you need to do, because as this is automatically supported, Spring Boot knows how to automatically configure your application to talk to one of these containers. But if you are trying to use any other technology that is not listed here, you may need to explicitly configure it. But how are we going to leverage other technologies and still use Docker Compose support? Let us see that. Let's say for the same application we are going to use Kafka as well. So let us add Spring for Apache Kafka support, and if you try to explore and see whether it is defined in the compose.yaml file, you can see there is no Kafka service defined here. So because it is not out of the box supported. So here I have manually added Kafka dependency services here in the compose.yaml file. We have zookeeper defined, and then we have defined Kafka, and we have configured, usually without Spring Boot support, how we usually define these services. The same way I have configured Kafka and zookeeper in the compose.yaml file. Because Spring Boot Docker Compose support doesn't have automatic configuration support for Kafka, we need to explicitly configure those properties here. And in the compose.yaml file, we defined Kafka service and then we mapped the port onto 9092 on the host. So when you run this services, it is going to run on 9092 on the local host, right? So we can configure those properties, like here I have configured bootstrap servers localhost 9092, and all other properties like what is the key serializer, value serializer, and consumer properties. So typically how you configure your Kafka application, you need to configure in the similar way. Okay, so how does it work? Because basically this Spring Boot Docker Compose support is going to run Docker Compose up -d and start all the services that are defined in this compose.yaml file, and it is going to start all the containers, MariaDB and Zookeeper, Kafka, everything is going to be started. Only thing is, Spring Boot Docker Compose support knows how to automatically configure MariaDB. It is going to automatically configure your application to talk to this instance, but there is no out-of-the-box support for Kafka, so you need to explicitly configure those properties in your application properties file. So all Spring Boot is going to do is, it's going to start all the containers defined in this compose file. Okay, so that's why you need to explicitly configure only for Kafka but not for MariaDB. I mean, it is not specific to MariaDB. You can use Postgres, MySQL, Oracle, any of those containers, and Spring Boot is know how to configure that with your application. So that is how. So let's see, we have configured Kafka here, and how can we use that? So here what I am doing in my bookmark controller, I have auto configured Kafka template here, and then once I create a new bookmark and after I save that into the database, I am publishing an event, and in this publish event method I am creating a new bookmark created event, which is a simple record with a few properties here, and I am publishing them onto demo topic here. Okay, so once I publish this, there is a bookmark event handler which is going to simply having this Kafka listener on the same topic, and we are simply logging it. So it's a very simple usage of Kafka. So now let us go ahead and start the application, and it should start the containers. So here you can see it started Kafka, MariaDB, Zookeeper, all these containers here, and our application is configured to talk to those services. Okay, now let me go ahead and make a API call here, and I am creating a new bookmark. Okay, it is successfully created. Now here I can see in the console a received bookmark created event, and it print the details here. So it is working fine. So that is how simple it is. Even though you are using some of the technologies that are not supported out of the box, you can still define those services in the compose.yaml file, but only thing is you need to explicitly configure them. Okay, we have learned how we can leverage Spring Boot's Docker Compose support for running the application locally, and we can configure whatever the services our application uses in compose.yaml file, and we can run our application locally. But Spring Boot Docker Compose support also supports for testing as well. So by default, Spring Boot Docker Compose support disabled for tests. So we can activate that using compose.skipInTest. By default it is true. Now you can set it to false. So here you are enabling Docker Compose support for testing as well. So once we enable this property, I mean skipInTest is set to false, that means we are going to use Docker Compose support for tests as well. So if you configure this property, and then here let us take a look at one of our tests here. So here we have a Spring Boot test annotation which is going to be an integration test, and then we are configuring rest assured to talk to the random port that is started, and then we are making an API call to /API/bookmarks, and also we are creating a new bookmark. So basically, if you want to run this test, you need to have an instance of database and then Kafka, and then only you will be able to run this test. Usually you have two choices. Either you can use this Docker Compose support, or typically we can use test containers for this. So in this video, let us see how we can use Docker Compose support. So here in this, by just defining this property, it is going to, when you run this test, Okay, when you run this test with this property set to false, it is going to start the containers that are defined in the compose.yaml file before running the test, and then it is going to run the tests as well. So now let us run this test and then see whether it is going to run just fine or not. Here you can see the containers are started, and then your tests are executed and everything is working fine. So this is how you can leverage the same Docker Compose support for testing as well. Finally, let us take a quick look at some of the customization options provided for Docker Compose support. So here we have already seen what are all the containers that are supported with Docker Compose support, and if you want to customize a different image, you can do that. For example, in this case, there is a custom Redis Docker image that we want to use instead of the out-of-the-box Redis image. So you can configure whatever the custom image you want, but you can use this label to specify which service we want to leverage this for. So here we can provide this service connection Redis, so that it knows that it needs to start a container based off of this image, but treat it as a Redis instance. Okay, that is how you can use custom images as well. And also sometimes you may define some images and you don't want to have this auto configuration for this specific service. So then you can configure this property so that it is not going to auto configure your application to talk to this service. So this is one use case if you want to ignore some services. And also by default, it is going to check for compose.yaml or docker-compose.yaml and YML, YAML, all these variations in your project root directory. If you have a different path or different file name, then you can use this property to define where is this different file. Okay, and also you can customize some of the readiness checks and all if you want, and you can also configure the lifecycle management. We have seen how to use start and stop is the default one, but you can change it to start only, so that it just starts the containers once and then it is not going to stop even if you stop the application. And you can also customize what command to run if you are starting the application, stopping the application, and all those things. And also you can use profile support, where if you are running your application in a specific profile, you want to activate only certain services. So if you have such a use case, you can use profiles concept as well. So all in all, it is giving smooth developer experience by automatically providing this out-of-the-box support with the Docker Compose and making the local development much simpler. I hope you enjoyed this video, and thanks for watching. Bye bye.